Okay, so methane is a hydrocarbon fuel. It says it complete the word equation for the complete combustion in oxygen. So what we need to do here is methane is reacting with oxygen, and during complete combustion it produces water and carbon dioxide. There's 2 marks, so 1 mark for each of the responses that we have added. In complete combustion, give a reason why we get carbon and carbon monoxide. That's because there is a limited supply of oxygen. There's a limited supply of oxygen, which is why you only get carbon and carbon monoxide. So then we're told that crude oil is a mixture of hydrocarbons and it can be separated into useful fractions by fractional distillation. So here's my diagram. Name the fraction in figure 10 that is used to surface roads. So the one is a road surface is bitumen. That's a waterproof layer. Name the fraction that contains hydrocarbons with the lowest boiling point. So if you remember, as you go up the fractionating column, the hydrocarbons get shorter and therefore the boiling point gets lower. So the one at the top is going to be the lowest boiling point, and that is the gases. Carrying on, here we've got some relative amounts and demands for those different fractions, and it says which of the following shows the fraction where the relative demand is greater than the relative amount in the crude oil. So which one shows the relative demand is greater than the relative amount in the crude oil? So we have a quick look at this. The demand there is greater and the demand there is greater, and we've got a greater demand there. So we've got 3, and hopefully that matches one of the options. So we've got gas, petrol and diesel. Gas, petrol and diesel, which the only option is that one there. Cracking involves breaking down large chain hydrocarbons. Octane can be cracked to produce a molecule of ethene and a molecule of X. So what is X? So to work out the missing value here, all we've got to do is we have 8 carbons at the beginning, and then we've got 2 carbons that are formed, so that leaves me 6 carbons. So X is going to have a value of 6. Last little bit. Dodecane is a large hydrocarbon molecule. When one molecule is cracked, the products are shown here. Calculate the maximum mass of octane. So I want to know how much of this we could form when 340 grams of this is formed as well. Okay, so the best way to do this is, there's 2 ways of doing it. I'm going to show you one way. First thing to do is let's convert that to moles. So I'm going to put my little equation here, my triangle, which is that Mr. Moles is underneath the mass. So I'm going to work out the moles. So the moles is going to be mass divided by the MR. So the mass in this case is 340. The MR is 170. Just trying to find my calculator. So all I need to do on my calculator is do 340 divided by 170. So 340 divided by 170, and that's going to be 2 moles. Now the ratio in here is 1 to 1. So the ratio is 1 to 1. Therefore, I will have 2 moles of octane. So that's step 2. And then step 3, let's convert that to a mass of octane. So the mass is going to be moles times the Mr. So the moles is 2, times that by the Mr for this, which is 114. Times that by 2, that's going to give me 228 grams as a final answer. Mark-wise, 1 there and 1 there. And that's that question completed.